All right, here we are with the second part of lesson 2 for our exponential functions. Hopefully you had a chance to kind of look through these and try them, but I'm going to go through each one how I would tackle it. It doesn't mean it's the only way to do the question, but it's a way for you to check or get some explanation if you're struggling with any of these. All right, this whole inside the bracket, there's nothing inside the bracket that could be simplified or reduced. What I'm going to do is apply the power of a power law by putting the 3 through. So we're going to have a 3 cubed, which is a 27. We'll have an x, the 2 times 3 would be a 6. We're going to have a negative 4 times a 3, so that'll make y to the negative 12. So notice I'm not dealing with that negative exponent rule yet. I'm applying another exponent rule first, and then we should have a z to the 3. Okay, so at this point, I have a 3 to the positive 3, which is 27. We have an x to the positive 6. It stays up at the top here. We have a y to the negative 12, so I'm going to make this now into a fraction and slide that y to the bottom and make it to the positive 12. And my z to the positive 3 is going to stay on the top and be z to the 3. And that's it. That's all we do with that one. All right, let's take a look at part B here. We have negative 8 divided by a 2, that's negative 4. I have an a to the 4 divided by a squared. 4 take away 2 is a 2, so that's an a squared. And then 7, take away a negative 2 would be the same thing as 7 adding 2, so that should be a b to the positive 9. So no negative exponents at this point. I didn't have to worry about the negative exponent rule. All right, part C, I'm going to multiply this. There's nothing inside that bracket that can be simplified, nothing inside the second bracket that can be multiplied. It's a monomial times a monomial. 4 times negative 5 is negative 20. A cubed times an a to the negative 2, keep the base. 3 plus negative 2 is just a 1, so that's just going to be an a. B to the negative 2 times b to the positive 4. Negative 2 add 4 is positive 2. And then c to the 6 times a c to the 6. 6 plus 6 is a 12. So we get negative 20, a, b squared, c to the 12. All right, part D, 6 divided by negative 12. Well, 6 divided by negative 12 is the same thing as negative 1/2. Okay, so I'm going to look at this like I can reduce that, and that becomes a 1/2. I'm going to slide the negative to the top. I'm just going to move this line. It was a little close. I'll try that again. Equals, I'm going to keep the 1 on the top. I'm not going to write it in because we normally wouldn't write it in. I am going to slide the negative up to the top so it doesn't get lost being down on the bottom. So I've just taken care of the 6 and the negative 12. That becomes a negative 1 over 2. Now I have an x to the 5 being divided by x to the 2. 5 take away 2 is a 3, positive 3. So I'm going to have an x to the positive 3. I have a y to the negative 2 and a y to the positive 4. Negative 2 subtract 4 is negative 6, so that'll be a y to the negative 6, or make it on the bottom y to the positive 6. And then I have a z to the negative 3, take away the negative 1, that becomes a plus 1. Negative 3 plus 1 is negative 2, so a z to the negative 2 could slide to the bottom and become a z to the positive 2. All right, so that's my final answer for part D. If you need to do that in steps, it's quite okay. Take some steps. In the end, as long as you end up at the same spot, we're cool. All right, part E. Now, these get a little bit more complicated on this, the last two examples here. I have a monomial times the monomial on the top, so one term times one term on the top, and then a divide by something. I'm going to look at simplifying the numerator first of all. So negative 6 times positive 3 is negative 18. And then I have, got an extra little spot there, here we go. Then we have an x cubed times x to the negative 2. Bases are the same and we're multiplying. Add those exponents, I just get an x to the 1. Negative 4 add 6 would be a positive 2. So a y to the positive 2, and then we have z to the 1 times z to the 5, that'll be a z to the 6, so 1 plus 5 is our 6, and that has to get divided by negative 2x squared, y to the negative 6, and z to the positive 3. So I didn't do anything to the bottom yet. All right, now this is like a question that we had previously. Negative 18 divided by negative 2, that will be a positive. 18 divided by 2 is 9. X to the 1 divided by x to the 2. 1 take away 2 would be a negative 1. I'm still going to have an x to the positive 1 on the bottom. So I slid that to the bottom. Y squared, so I've got a 2 take away, and then the negative 6. 2 take away negative 6 would be like adding 6, so 2 add 6 would be 8. So that's going to be a y to the positive 8. It stays on the top. Not sure why my stylus is not working so well tonight. We have a z to the 6 divided by z to the 3. 6 take away 3 would be just a 3, and it's a positive 3, so it stays on the top. Z to the positive 3. So that should be your final answer. Again, if you need more steps, please, by all means, take the extra steps and do it right than trying to race through it and then not get it correct. All right, part F, we've got a lot of stuff going on here because I've got power of a power happening. So I've got to apply that exponent to each of the brackets that we have here before I can do the multiplication like I did in part E. So that 8 gets an exponent of 2. The a to the 6 gets the exponent of 2. That makes that a to the 12. The b to the negative 4 gets the exponent of 2. That's going to be b to the negative 8. And then we have a c to the positive 4. So that is going to end up getting multiplied by this next part. We have a negative 4. I'm going to put a little bracket around that negative 4. That's to the negative 3. And then we have an a to the positive 9. Negative 3 times negative 3 is positive 9. B to the 2 times negative 3 is negative 6. And then C to the negative 3. Can I squeeze that in here? There we go. And that is all over. I have a negative 2, which is going to get an exponent of negative 1. An a to the negative 2. So I'm just multiplying those exponents together. We have a b now to the positive 5, and we have a c to the negative 4. So I'm not going to move my things around in terms of ups and downs yet. I'm going to try to evaluate some other pieces to this. All right, the 8 squared I'm going to leave on the top. It's going to stay there. I'm going to multiply that with the negative 4. So I'm just moving the things I would normally multiply together side by side. So that's my number part there. I have an a to the 12 times an a to the 9. 12 plus 9 is 21. So I have an a to the 21. Negative 8, add negative 6 would be a negative 14. So b to the negative 14. And then we have a c. 4 add negative 3 would just be a 1, or just c. And that's still all over negative 2 to the exponent negative 1. My a to the negative 2, b to the 5, c to the negative 4. Alrighty, we're getting there. Now, let me see here. I'm going to deal with the number parts here. My a to the 2, it's a positive exponent. It's going to stay on the top, but these two are going to switch positions and switch the exponent signs. It doesn't switch the sign of the base, only of the exponent. So the 8 to the 2 stays on the top. I'm going to slide that negative 2 up to the top, and that's now to the positive 1. And then I'm going to take that negative 4 to the negative 3, slide it to the bottom, and make it to the positive 3. All right. Now, the a has a 21, and it's divided by a to the negative 2. So 21 take away a negative 2 would be a positive 23. So that's going to be a to the 23 on the top. I have b to the negative 14. Negative 14 take away the 5 would be b to the negative 19. So I would either write b to the negative 19 on the top, or I can automatically slide it to the bottom and make it to the positive 19. C to the 1, take away 1 take away negative 4 would be adding 4. 1 plus 4 is 5. So that should be a c to the 5. All right, and the last thing I'm going to do here is actually evaluate the number parts here. I have an 8 squared, which is 64, and then 64 times negative 2 would be negative 128. And I'm just doing this in steps. I don't have my calculator in front of me, so I'm going to take a couple steps here. 4 times 4 is 16, and 16 times 4 is 64. And it's going to be negative because there's 3 negatives being multiplied. Now, I've got a 128 divided by 64. Holy crap, those are big numbers. But I'm going to use what I have up top here. I'm going to show you something. This 8 was really a 64, and this negative 4 cubed is really negative 64. Okay, so if I look at negative 64 divided by negative 64, that's going to end up equaling -1. So that part overall ends up being a -1, so it's really like I have a -1 times this -2, which then gives me a +2. So that tells me 64 goes into itself once and into 128 twice. So overall, because I don't have my calculator in front of me, I know that should be +2, a to the 23, c to the 5, all divided by b to the 19. I hope you had fun. All right, and now you've got some more questions to try on your own.